Now we move on the session number 3 in the model 5 of condensate model. In this session, we need to learn about modifying the regression rosette. Modification of the dataset is very important, and now we may improve the regression of the volumetric data and the saturation ratio. You should begin by opening the component selection properties from and viewing the column for the volume shift parameter. Note that some of the components have the default volume for shift of 0. You can see and have a look in this interface. And when you right-click on the volume shift column and select the interface correlation value, and you will see a lot of information about volume shift coefficient. And I mentioned some component already set default A0, so this is the default of the software. After you have a look on the information and observation, you need to apply trend by clicking on this button. And the next step, what should we do? You need to open the regression parameters, saturation reservoir on the calculation tab, and then you enter the value about 50 for the weight associated with the experimental saturation ratio value. This value is to ensure that the saturation ratio is more closely matched. At the same time, on the column deletion form, you go to the ratio level tab in the way of 5 for the liquid saturation value as shown below. And when you have a look in your software, it should be have the interface similar with this photo. And I call that the modified weight factor for liquid saturation. Okay, so after that, you need to open the regression parameter form and add the volume shift parameter for methane and C7 less kilo components. Add the regression variable as shown below here. The additional regression parameter will be depend which one you would like to get for your machine model. So I would like to make the long note here. After you save this dataset as the condensate regression to.dat and run the dataset again. Note the degree in the residual value. You check the mark to the liquid dropout on the CVD summary loss. At the same time, you view the summary table in the output file to observe the effects of increasing the weight for the saturation ratio of experimental data. It helps you to further improve of the fit by attend using Windrup regression variable grouping method. The grouping method ensures that existing trends in the original component properties are maintained by implementing or decrementing on the members of a group by the same amount during regression. Since each group is treated as a single regression variable, it also provides a method for varying large number of component properties without having to select them as the individual regression parameter. So what is the next step for modifying the regression set? We continue with the next slides. Okay, you go to regression parameters, component properties tab, clear the selection of critical ratio and volume shift for the component C07 to C09 through the C15 to C17 by clicking on the cells marked with an X for those components. and leave BC and volume shift selected for component C18 plus. Then you need to select the reticle temperature and altitude factor for C18 plus. In the selection group field at the bottom of the form, you click on the arrow, then select new group, and click on the cell for the component C07, C09, group C15 to C17 in the reticle raster column. Okay, you can observe in the interface here. So, and after you select the regression parameter component property, you need to save this file as the condensate regression tree of that and run the dataset with the new regression specification after you select it here. Okay. So in this simulation, okay, the residue is reduced significantly, indicating that much better fits have been obtained. You need to check the output file to verify that related saturation ratio now match the experimental value quite slowly. The CVD summary should show good match of the liquid dropout as shown below here. And you see the boy is the experimental data and the curve is the simulation. And similar for the rodeo gas as well. It shows very good matching between the simulated and the fitting experimental data for the liquid dropout matching process. So why this is a good match? A better result can obtain by adding the binary interaction parameter between methane and the phi C7 lead component separated from the binary interaction coefficient correlation using in WinRub software. In the component selection property, set the hydrocarbon to 0 for the C7 plus component as shown in figure A. We conduct the component hydrocarbon adjustment. And then the regression parameter window under this interaction, we conduct the coefficient stop select the interaction parameters between methane and C7 lead component a regression value. You can clearly see here in this interface. Okay, this is the last slide for the session number 3. You need to set this file at the condensate regression 4.dat and run with WinRub. As shown below, the liquid dropout is very well matched now. Okay, you can see. And we will meet again in the next video for session number 4 to perform the condensate phase behavior model using WinRub.